Well, another problem that I have usually in these sessions is when people see my title over there, which is a product marketing manager, people usually stop talking to me because I don't want to hear about the marketing stuff. Well, I do have a technical background, and the only difference from a technical person in the marketing team and the marketing person in the marketing team is that I can talk about technical stuff and I still have fancy slides, so that's the only difference, right? Well, I work in the Windows Server team, and I specifically, in my role, I cover the security investments that Microsoft does in Windows Server. And I also cover some of our VMware Compete efforts as well. We can talk about those things. I also have 2 sessions tomorrow. One is on software-defined data center, and the other one is in application platform. So if you're interested in containers, nano server, or in the investments that we did for software-defined data center, I also invite you to come to my sessions tomorrow. Before we get started, actually, the way I like to do this kind of presentation is, if you have any questions, just raise your hand, ask the question. Because we don't have any mics in the room, I'll repeat the question, so I'll make sure that everybody hear the question, and then we can talk about. I like to talk to you guys, not just and have a conversation, not just myself talking here and talking about the products. I like to answer the questions that you guys may have. And I'll be here afterwards, so if you still have questions after the session, feel free to come and we can answer the questions as well. Because I like to have this conversation, let me ask you a few questions, actually. Let me start by asking you some questions. Who in here consider yourself as a developer? Any developer in the room? No? Can we say bad things about developers in this case? Yes? Okay. So I'm assuming that if you're not a developer, you probably are IT pro. Who is an IT pro here? Okay. Who in here is, I don't know, database administrator maybe, as part of the IT pro role probably as well? Okay, anyone that is not getting your hands dirty, you are above the technical, looking for, I don't know, maybe CIOs or CIO -1 or, okay, cool. Well, good to know. So this session is to talk about security and what are the investments that we did in the platform to support this broader security investments that Microsoft is doing as part of our cloud efforts, as part of our devices effort, data, and so on. So who in here was in the session that Jeff Woolsey delivered in the morning, the general session for infrastructure, that he talked about some of the things that we did for security? Anyone? Okay, some of you guys, okay. He mentioned one of the numbers that I'm going to show you, and that number is really impressive for me. So I want to start this conversation actually pointing out the reasons why Microsoft decided to invest so heavily in security. And this is the state of the union in terms of security right now. So we have a lot of other numbers. Those are all impressive numbers. The one that is more impressive for me is the one in the middle. $5 million is the average cost of a breach for the companies out there. So let me ask you another question. Has anyone here been breached in the last couple of years? Okay, so the other ones, how many of you guys don't know that you are being breached? That's an important one. That's an important question because one of the things that we are going to talk about is what are the attack vectors, what they have in common, and how usually they occur. These are the things that you guys are probably familiar with, right? So what are the attack vectors that we see in applications and the regular infrastructure that you guys are probably managing? We see attacks to identities. We see attacks to vulnerabilities that are not patched in the system, and many other vector of attacks, but Well, if you've been in the industry for a while, you probably know what are the attack vectors that occur in order for a breach to happen, right? And if we think about, for most of these things, we did something as an industry, not as Microsoft, and as an industry, to solve the problem of those vectors of attack, right? So think about compromised privileged accounts. We make sure that we have processes, we hire only people that we really trust, people start as junior and they go in their career to become a full administrator, unpatched vulnerabilities. Well, Microsoft has a very long story in talking about updates and how we handle those. We have a very, I would say, not complex, but very sophisticated system to help you guys keep updated and so on. Phishing attacks, malware infections, all of those vectors of attack, we did something to control or mitigate the risks of those vectors of attacks, right? Now, when we move from the regular way to do IT to the cloud or whatever modern or fancy word you want to use, we have new vector of attacks that we didn't think about. We don't actually have an answer for everything. So if you think about compromised fabric that exposes guest virtual machines, right? If you think about how easy it is for an administrator, not just to change the virtual machine itself, but to do things in the environment that will not be noticed by anyone unless you are you have some kind of control on top of your administrators itself, right? So there are new vector of attacks that are present today because we are moving from a traditional way to a more agile way of doing IT, right? And those are the things that really drove Microsoft to do the things that we did for Windows Server 2016. The other important information here is how an attack what an attack usually looks like. So if you think about the moment that you are, that the attacks start to happen, actually there's a lot more going on before that. So as an attacker, if I want to have access to a company or an enterprise or whatever it is, I will do some preparations. And the thing is, we have no way to measure how long it takes for an attacker to actually educate itself on how that company works. We only know when the attacker actually starts the process of attacking that company, right? And one of the things that we measured based on many customer information, our internal information, and so on. But this is basically internal research from Microsoft. Usually it would take from 24 to 48 hours for an attacker to be able to penetrate the environment. If that doesn't scare you, I don't know what you guys are afraid of, right? And actually, this is the average. Many companies have been breached in less than 24 hours. We are talking about minutes, right? The next problem we have after that, because the process of attacking a company usually will target an identity, and from that identity I can have access to many resources. Usually attackers target domain controllers, right? Because with a domain controller I can have access to all the identities, and then I can stay inside of the environment without being noticed. So that's the problem that comes afterwards. So usually an attacker will be able, see, fancy slides, transitions. So usually an attacker will stay more than 150 days inside of the environment without being noticed, right? That means I have as an attacker, I have 150 days to extract all the data that I want, and only after 150 days, you guys will notice that someone breached your environment and the information is already out there, right? We have a lot of cases. Usually we don't say names of those cases, but some of them are public information. Like, you guys heard about the FDIC breach that happened last year. Actually, the breach happened a few years ago. And the FDIC, if you guys don't know about it, as a Brazilian, I know what the FDIC is. Basically, they are the agency, I don't know if that's the correct term or category, that basically looks over all the financial system in the United States, right? They have been breached, and their CIO basically did not provide the information to all the agencies that he should report to. And last year they discovered the breach, and they discovered that the CIO did not report the information that he should. This is very scary. The only reason why I'm not that scared is because I was not living in the US the moment that the breach happened, right? So we look at this, and we started to think, okay, so what are we doing not only to prevent that breach from happening, but also, if that happens, what are we doing to actually make the process of identifying a breach easier, right? So one of the postures that we talked to a lot of customers about is the assume breach posture, right? And we don't usually talk about this in our marketing assets. And the reason why is because if you don't explain what that means, people will understand assume breach as, okay, Microsoft is not doing their job. They want us to assume breach. So they're doing products that are not secure. We have to assume breach. We have to use the assume breach posture because of that. That's not the case. What we are saying is that for many reasons, there may be an attack, and your company may be compromised. So you need a way to see what's going on inside of your environment, and you need to be notified if something happens. So when we talk about security in the Microsoft space, we are not talking about just Windows Server. We are talking about a very broad set of products and services that will help you elevate your security posture, right? But the thing that we want you to understand is you need to ensure that not only someone can penetrate your environment, so you need to prevent that, but we also have to understand that we need to do something if someone is able to penetrate your environment. Does that make sense? Yes? Okay, so I was saying earlier, most of the attack vectors that we see today, they have something in common. The thing that they have in common is that at some point, they will need some kind of access that is provided by only a few identities inside of your environment to have access to the information that they need to access, right? So what the attack vectors have in common is that at some point, they need to have access to the privileged identities inside of your environment. Think about pass the hash, rug administrator, whatever vector of attack that you can think about. These are the things that they are after. So they are looking for the privileged accounts. So first thing, these privileged accounts, we gave access to administrators years ago. Actually, when we were planning Windows Server 2016, we thought about why don't we lock down the Windows Server box and we keep the administrators out. Can we do that? Yeah, we could. We decided not to do it because, well, the way people are usually managing their servers, that will cause more problems than actually solving problems, right? So we decided to adopt another option. We're going to talk about that. And also, another problem that we have, actually, let me move to the next slide. We're going to talk about some of the things that are here as well. So as we evolve from traditional way to do IT to large-scale data centers, agile IT, whatever you want to call it, the risk associated to identities has only grown over time. So if you think about a single computer if I can have access to that single computer, I'm limited to whatever is inside of that machine or whatever that machine or account has access to, right? As we move it to a virtual environment, if I have access to the virtual host, I can now have access to the multiple virtual machines running on top of that. And that gets worse once I move to a hosted environment, because in a hosted environment with a public cloud or a private cloud, now I have access to multiple assets that run on this fabric, right? So the problem is not just that we gave access to administrators, and if that account is compromised, they can have access to the information, but now they have access to information of multiple tenants or multiple customers or things that they shouldn't have access to, and there you go. So we want to go back to the point where if something is compromised, the limits on what that can be accomplished is limited. So the other approach that we are talking about when we talk about Windows Server 2016 is something that we call layers of security. And what layers of security is basically saying, if someone is able to pass the first wall, they will be limited to that space. They have another wall, right? Different than actually doing what we used to do in the past. That in the past, what we used to create big walls, right? And if someone is able to penetrate that wall, they have access to everything. What we're doing now is we are building multiple walls, because if someone is able to penetrate the first, they have another layer. If they pass that layer, they have another layer. And they are always limited to those layers. So if we go back to that slide that says 24 to 48 hours, one of the things that we are trying to do with Windows Server 2016 is actually make that time period very much longer, because if we can do that, then you guys can see what's going on, that something is not right inside of your environment, right? Okay, and well, we learned a few things while we were building Windows Server 2016, right? I'll mention just some of these. I know you guys want to hear about the features. So the first thing is the network is not your security perimeter anymore. Your identity is, right? If I have access to an identity, and that identity has some kind of access inside of your environment, you're done, right? You're pretty much done. If I can have access to a domain admin credential inside of your environment, let me give you an example. How many of you guys here use Active Directory? Awesome, thank you guys for doing that. Did you know that I can create a user object under a printer? If you think about the way Active Directory works, Active Directory is based on a structure of organizational units and objects, right? Every single object can contain another object, including printers, right? Now, I can't do that in the user and computers interface of Active Directory, but I could use other tools to do that. Imagine if I have access to a domain admin credentials, and in 5 minutes that I have access for that credential, I can create a user account under a printer, and then I can hide myself inside of your environment. You can change the password for the account that you created. You can delete the account, but you can't see an object inside of printer from the usual tools that you have. Now, the information is there. You need tools to help you identify those kind of things, right? Another one that is, that is interesting, eliminating human error isn't possible. And this is probably the most important one here. A few years ago, well, I've been working with Microsoft technologies or in products and services for, 15 years now. I remember when I was still working on help desk as a support analyst, one time that someone opened a ticket for PC that has some kind of malware on it, and we discovered that the person that was the owner of that PC, it was a woman, and she received something that was very common in Brazil a few years ago, like those electronic cards that you receive with some kind of cool message. Someone sent you another one. Anyway, they were very popular a few years ago in Brazil. And she received an email saying, you got a card, an e-card. Click here to see the message. Guess what she did? She clicked, right? We went there, we cleaned up the machine and so on. We explained to her that was a malicious email. And then she asked me, okay, thank you very much for doing that. Where's my card? No, I don't think you understand what's going on here. There's no card. No, the message says that I have a card. I understand that it was infected, you cleaned up, where's the card? If that person received another email the same day, she was going to click again, right? So, no matter the level, even us, we make mistakes, right? So we have to account for those mistakes as well, right? And there are a lot of things that we learned that we need to take in account when we create a product like Windows Server. Now, based on all of that, this is the posture that the Windows Server team adopted when we were creating Windows Server 2016. The first is also, and the more obvious one, we want to help you protect your environment, right? But that is not enough. We need to provide some tools for you to help you detect what's going on inside of this environment. And a lot of the work that we did on this part, on this item here, is actually along with our friends in Azure and in our data centers. And the reason why is because they have a kind of a infinite compute power, right? That can help you see what's going on inside of your environment. And based on things like machine learning, they can see what's going on. They can see some kind of things that are, for a human being to be able to realize things like that, it will take years if they were able to see something like that, and they can notify you of something that's going on. For example, one of the things that's very common in most of the customers that start using tools like Operations Management Suite, for example, they start to get some logs, and we start to analyze those logs, and we show things like someone is trying to log from China, and 5 minutes later, they are logging from the US. Unless you're Marty McFly, you can't do that, right? But how can you, as a human being, look at millions and trillions of logs and see something like that? We just can't. But using the power of the cloud, we actually have the tool now to do those kind of things, right? The third one is respond. And respond is really stop the attack and actually see what is the best action to take to move forward without compromising the other assets that you have. And the four, this is not exactly an order, right? So another important step here is to isolate, right? Remember the layers of security that I mentioned? We need to ensure that if they were able to breach, they are limited in terms of scope on what that attack can do, right? Okay, any questions so far? I'll start talking about the features now. Some of the features you may be aware of, and one of the things that I wanted to remember is that these are the features that are inside of Windows Server 2016. It is not for sure the comprehensive list of things that you should consider in your data center, right? We are talking about Windows Server 2016. So the first thing that I want to talk about is how we can help protect the privileged credentials that you have inside of your environment. And when we say privileged credentials, the reason why we say that is because when we think about Windows Server, we are talking about the data center. And in the data center, you have to think about everyone is an administrator of something, right, inside of the data center. Now, with that said, some of the features that we have here are shared with Windows 10 as well. So some of the things that we are going to talk about are similar in nature in terms of the vector of attack for Windows 10. So we actually built the feature in the kernel, so both Windows and Windows Server will have the same feature, right? Now, what is the problem of, what is the challenge in terms of protecting the credentials inside of your environment, of your data center environment? Well, social engineering leads to credential theft, and at some point, someone will be able to have the password for an account, at some point, right? Most of the attacks will target, as we were talking about, the identities, and through pass the hash, pass the ticket, many other vector of attacks, they end up having access to privileged accounts and then have access to domain controllers and then game over, right? Again, administrators have access to usually more, usually they have more access than they should have if we really think about it. Let me give you an example. Again, Active Directory, since this is a common workload inside of your environments. Can I manage a domain controller, or let me rephrase that. To be able to manage a domain controller, what is the minimum level of administration that I need to have in order to log to that domain controller? Does anyone know? Domain admin, right? I need to be a domain admin in order to log to a domain controller, no matter what is the purpose that I need to have access to, right? Let me give you an example. Along with Active Directory, there's another role that is installed in the domain controller. What is that role? DNS. Now, in many companies, because of the separation of duties, they will have only a DNS administrator, right? Apart from the domain controller admin. Now, in order to log to the domain controller where the DNS server resides, I need to be a domain controller. You guys see the problem? I need to have a much broader set of access in order to perform my job than I really need. So if my account is compromised, I end up having access to other things that I shouldn't have, right? Again, how can we protect against those vectors of attack? Well, and this is the fancy animation that I was talking about, that as a technical person, I always forget about it. Anyway, so these are the features that we created or that we built in Windows Server, along with Windows 10 as well, in order to protect the credentials inside of the data center environment. Credential Guard and Remote Credential Guard. Now, if you guys are familiar with the pass the hash attack, you guys know that what they are targeting with the pass the hash attack is the NTLM hash, right? Because if I can have access to the NTLM hash, I basically can move to the side, right? So I can move to other workstations, and if I end up in a workstation that a domain admin logged on, I then can move up to the servers and then end up having access to domain controllers. So the reason why the NTLM hash is still stored in the Windows system today is because many companies that we talk to, they still have legacy systems, and they are still using like printers or whatever device it is that connects to the Active Directory and do some kind of authentication. They are still using legacy authentication protocols, right? So in order to maintain compatibility to those systems, we have to maintain NTLM hashes available for you guys so you guys can have those kind of devices log into your systems. We maintain that. We understand that this is important for you. We provide all the documentation on how to stop that, how to stop the NTLM hash from being stored on the PCs. But at the end of the day, there can be misconfiguration or person is not aware of that. Anyway, we have to assume breach, right? So what we did in Credential Guard is, and that what I'm going to explain for Credential Guard is actually the foundation for many of the things that I'm going to talk about. One of the things that Jeff mentioned in the session that he did earlier, by the way, there's a repeat for that session tomorrow, is the virtualization-based security feature. So virtualization-based security, Jeff did not explain what the feature is or what the technology is. So basically what we do is, you guys are familiar with the hypervisor technology and architecture, right? You know that every single virtual machine is isolated from each other because of the hypervisor, right? Now, when we talk about isolation, that's one of the principles for the security capabilities that we are looking for. So virtualization-based security is basically an area inside of the hypervisor that is isolated from any area that an administrator that have access to the system would be able to access, right? Because that area is isolated, everything that the Windows Server system stores inside of that area, an administrator can't have access. Now, what we are doing with Credential Guard is we are storing the NCLM hash inside of the VBS area. You see? So if I'm an administrator or if I'm an attacker and I try to see the NCLM hash in that system that I was able to attack, I can't, even as an administrator, because now the hash is stored in that area that I can't have access, right? The remote Credential Guard is we call it the sister feature, because if you, by the way, Credential Guard is shared with Windows 10 because that makes sense for clients as well. Remote Credential Guard is a server feature because if you think about servers, we usually don't go in front of the server and log to that server. What we usually do is we RDP to that server, right? We remote connect to that server. So in order to protect that login as well, we use the remote Credential Guard now to be able to protect the RDP connection as well, right? The other two features that we added to Windows Server 2016, they are not only for Windows Server 2016. By the way, they work, these two features, just enough and just-in-time administration, they work as well with Windows Server 2008 R2 and above. Just enough and just-in-time administration, we basically, what we're trying to do here is limit not only the scope of actions in terms of capability that an administrator will have, as well as the time that that administrator will be able to perform that action, right? So think about an administrator at a regular domain admin account. If you think about capabilities, they can do anything inside the system, right? DNS administrator, they have to be domain admin. Time, anytime that they try to log to the server will be available, right? So just enough administration is actually, taking a step back again, these two features, they are not dependent. They can be implemented separate, but we highly recommend that you look into the two features to deploy them together. The reason why is because you focus on capabilities and time as well. Just Enough Administration is a PowerShell-based tool inside of Windows Server 2016 that can work with Windows Server 2008 R2 and above that will basically limit the scope of actions that administrators will have inside of any given box or system inside of your data center, right? So think about a DNS administrator again. What are the PowerShell commands that DNS administrator can perform? Well, of course, if you allow him to, all of the DNS set of commands for PowerShell. But as a DNS administrator, shouldn't I be able to use the restart service to restart the DNS service? The problem with giving the restart service to someone is that if I allow him to run the restart service, they could restart the MTDS, for example, which is the Active Directory service, right? So with GIA, you can not only say what are the commands that that person is able to perform and what are the targets what are the servers that he's able to manage, as well as what are the parameters that they can give to a given command. Like restart service, he can only provide the DNS server value for that specific command, right? How you do that? There's a XML file that you can configure. We have a set of files that we provide to you in order for you to get started. But basically, you say, what are the targets, what are the commands, and what are the values that that specific administrator can provide when he's managing the server, right? Just-in-time administration is a little bit different because what we are trying to accomplish with just-in-time administration is actually if he needs to perform an administrative task or action, he will need to go to a web portal and request elevation, right? So at the end of the day, from now on, no one is an administrator, but if he needs to perform his job, he can go to a web portal, ask to be an administrator. He will be an administrator for 30 minutes, 1 hour, whatever time that they need to perform his tasks. And after that, he is no longer an administrator in the system. Does that make sense?
What's that authenticator? Like, who approves that, or how's that?
That's a good question. So the question is, who approves that process? It's a workflow. You can set who is the person that approves. Actually, there are many ways that you can do that. You can only have the portal for login purposes. So there's no approval, right? So why are we asking for elevation? Because you want to log. You want to have a log that someone was elevated, right? Or you can go through an approval process. I ask for elevation. Someone gets an email, approves the process, and then I can perform the actions that I need to, right? Not the way it works today. You could work with System Center Orchestrator or Azure Automation to get something like that. You will need to have some kind of alert that triggers an automation runbook in order to do something like that, but you could. Okay, so let me go ahead. Oh, before I go to the demo video, one of the things that we did was, well, there are many things out there from the Microsoft scope of products and services, as well as from third parties that you guys could use in order to protect the privileged credentials inside of your environment, right? What we did was we spent some time with our customers and some people from the Microsoft consulting services in order to say, okay, so what are the things that I need to do to protect the credentials in the data center, right? So I'm not talking about client. Of course, there are some things you have to do to the client to protect your data center, but what are the things that I need to do in a data center to protect the administrative credentials that I have in my data center? So instead of just listing a lot of stuff, we did a research to see what are the things that I really need to do and that I can do that are very quickly and very easy to perform. And we established a 3 phases plan. So this is a recommendation from Microsoft. It's publicly available. I'm going to give you the URL so you can access it. So we divided in a plan that is a 2 to 4 weeks plan, then 1 to 3 months, and then more than 6 months. So what can I do that is easy to do that will elevate the posture, the security posture that I have in my environment? First of all, separate the admin accounts from the regular accounts, right? If you log in your machine as an administrator of the domain, it's wrong, right? You should have a different credential to do that, right? Also, you should have a workstation just for administrative tasks, right? So this is a recommendation from Microsoft. The Labs tool, so the Labs tool, if you're not familiar with, the Labs tool basically randomizes the passwords of the administrators, in the local administrators, both in workstations and servers. So very easy to accomplish, not very complicated. you can see that we have some links in each of the actions here that you can explore in more details with what each of the actions here are. And this is the 2 to 4 weeks plan. And then we have the other part, the 1 to 3 months. So let me open all the items here. So things like just enough administration, just-in-time administration, the ATA, the advanced threat, I don't remember. So too many acronyms if you work for Microsoft or if you work with Microsoft technologies, you know what I'm talking about. ATA is something that you should add to your environment to see what's going on inside of your domain controllers. Then some of these are not actually products, are just documentation on how to harden your Active Directory. You should be looking at that document in order to protect the credentials in the data center. And then we have the 6+ months plan, where we go to things that are more complicated, but once you do those kind of things, it will elevate a lot your security posture. Like, for example, shielded virtual machines for domain controllers. By the way, I'm going to talk about shielded virtual machines in a minute. Device guard with the code integrity policy for the servers that you have in your environment. I'm going to talk about this feature in a minute as well. So if you want to see what we are recommending for your data center, take a look at that URL on the top. Feel free to take a picture or just go to the aka.ms/privsec. All the information that I'm talking about here is detailed in this page. So with that, let me show you a quick demo on Credential Guard and Remote Credential Guard.
Let's talk about a mitigation that is able to prevent credential theft. We refer to this capability as Credential Guard, and it's available in both Windows 10 and in Windows Server 2016. To illustrate the process of credential theft and to emphasize the need for Credential Guard, let's imagine that we have a scenario where a DNS server has been logged onto by a domain admin, somewhat in opposition of best practices, I'll add, and it's also been logged onto by other trusted users from trusted forests. At some point down the road, the DNS server is unfortunately infected with malware. Since the DNS server hasn't been rebooted since the domain admin logged on and since the trusted user logged on, the credential artifacts of both users still remain in memory. The malware can then use these NTLM hashes to impersonate both the domain admin and the trusted user, until such time as they reset their passwords. The malware then removes itself, leaving no trace. Credential Guard, which is available in both Windows 10 and Windows Server 2016, mitigates this attack by encrypting those credential artifacts in memory. They're only ever decrypted within the secure confines of Virtual Secure Mode, and Virtual Secure Mode itself is protected using platform virtualization features. Credential Guard is enabled in the same way for both Windows 10 and Windows Server 2016, using the group policy setting that I'm showing below. It's also worth noting that Credential Guard has a sister feature, referred to as Remote Credential Guard. Remote Credential Guard allows you to log on to remote desktop servers using Kerberos single sign-on in the same way as you would a file server, thereby preventing your credentials from being passed to the server and being stolen in the process. To activate Remote Credential Guard, simply supply the /Remote Guard switch when running the Remote Desktop Connection tool. Remote Credential Guard is only supported on Windows Server 2016 servers and later.
So just to point out one of the things in this video, you notice that when he was talking about Credential Guard and he showed the GPO to enable Credential Guard, the name of the feature there is Device Guard, right? That's because Credential Guard is applied along with Device Guard. There's something that you have to apply from Credential Guard in order to enable Device Guard to enable Credential Guard, right? So let me explain what that feature is, and that takes us to the next item here, which is how can we help protect applications regardless on where you run that application? So what that means is one of the things that we are trying to do with Windows Server 2016 is, well, you may be running Windows Server outside of the Microsoft realm, let me put it this way. So maybe you're running Windows Server on top of VMware, right? You are running Windows Server on top of AWS. We have absolutely no control under the hypervisor or the host operating system, right? So one of the things that we are trying to do still with Windows Server 2016 is we want to make sure that Windows Server is the most secure OS possible to run your workloads. So there are things that we are doing for the hypervisor, for the host, but there are things that we are doing to the OS as well. So no matter where you run Windows Server, you have a more secure OS as well. So the first thing is if we have to think about what are the challenges in protecting applications. And of course, if we think about security, we have to think more broadly. So if I have a SQL database, I have to think about SQL security as well. If I have Exchange security. But there are things that are about the operating system. So first of all, there are things that we know that we can prevent, but there are things that we don't know that we need to prevent the attack from, right? And the other problem that we have is sometimes we apply some kind of security fix or approach that will also cause trouble to the legitimate workload that you have running in your server, right? So one of the examples, I have antivirus that every time it runs a full scan, it brings the performance of my web server down, right? This is one of the things that we heard from customers. Also, we have signature-based kind of protection, and we have things that we don't know that are out there. If you think about the multiple malwares that are created every single day, there's no way to protect against only with signature-based protection, which is most used in anti-malwares, right? So what are the things that we did for Windows Server 2016? The first feature is Device Guard. And Device Guard is, again, shared with Windows 10, so you can apply this to Windows 10 as well. And Device Guard is basically a way for you to whitelist what are the applications that can run inside of the system. Do you guys know any other feature that does that? A lot of other tools and features and products that can do that, right? So what is the difference between Device Guard and whatever other product that you can think about that creates a whitelist of features, things that are able to run in your server? The difference is Device Guard, remember the virtualization-based security that I talked about? So Device Guard uses the VBS area to store its policy, right? So Device Guard, you create a server, you run only the applications that you want to allow in that server, you create a base image based on that, and you generate a code integrity policy. You deploy this code integrity policy to the servers in your environment, and everything from the moment that the server boots that is different from that code integrity policy will be flagged or blocked. Now, as an administrator, with every single other tool, I could change the policy and run the malware, right? With Device Guard, you can't. You need to change the base policy to be able to do that, right? So that's the difference between Device Guard and any other whitelist software that you may be familiar with. Device Guard has two ways to be implemented. You can run as an auditing mode or an enforced mode. The difference is obvious. So auditing mode is just flagging what's running that shouldn't be running, and enforced mode is the application will be blocked, right? And I mentioned that the application is blocked from the moment that the server boots, right? So one of the vector of attacks that we identified was, in some cases, the attacker will reboot the server. They have physical access to the server. They reboot the server. They inject some kind of malware to the boot process, and they are able to, I don't know, see the memory, have total control of the operating system, and so on. With Device Guard, we are measuring along with secure boot, we are measuring what's going on with the server the moment the server boots, right? So if we identify that there's something that is not allowed in the code integrity policy from device guard that is running with the server, we blue screen the server. And the reason why we do that is because we prefer the server to die than actually run with a malware, right? So that's the real power of device guard. So really cool feature. And we use that with other stuff as well that I'm going to talk about. Defender is the regular Defender that you guys are familiar with, right? Defender has been out for a while for the client and even for server. You can install Defender for server even in 2012, if I'm correct. But the difference in 2016 is that first, it's native. It's already there. You deploy Windows Server. It will come with Defender. The only installation option for Windows Server 2016 that does not come with Defender natively is NanoServer. And the reason why is because there's a package for Defender that you can choose to upload to the NanoServer image. And another difference in Defender from the client to server is Defender in the server will recognize what are the roles and features that you enabled in that server, and it will not impact the workloads that you have running. For example, Hyper-V, it will remove from the scan processes from the Hyper-V that will usually impact the virtual machine if the antivirus is not aware of the Hyper-V feature. It's the same for IIS, Active Directory, and all the other roles for Windows Server. Control flow guard is another vector of attack that we identified is some attacks, they inject a malware to the server, and that malware tries to read the system memory from the kernel or from the operating system, right? There are many tools that do that. In Windows Server 2016, we basically block every suspicious, let me put it this way, activity from applications running in the server in order to protect the operating system. So if an application tries to read the system protected area, the system memory protected area, we basically block that tentative from the application to read that area, right? So just a moment. Control flow guard is enabled by default. You don't have to do anything. So by default, it will be running in the box.
With device guard, where you whitelist software that's already installed, how do you deal with patches?
So patches are part of the operating system, so you don't have to deal with patches in your whitelist for device guard. They run the system level, kind of.
Does Microsoft consider Windows Defender enough to protect the server from the malware perspective? Or would you also?
Yeah. So the question is, I'm sorry, I don't know if I repeated the other question, but the question here is, does Microsoft sees the Defender option as enough for enterprise-grade companies or things like that? You have to look from two perspectives to your antivirus / anti-malware solution. The first is this solution protecting against malwares? And the second is, does this solution provide the level of management that I need in my environment? The first question, yes. So we work with the industry. We have, well, this is kind of a longer conversation. We have an entire global team that collects samples of malwares. We have an entire team dedicated to create the signatures. So yes, in terms of protection, yes. And we are back to the rating systems where Defender is being evaluated with other tools. We have been, we got the highest levels of ratings and so on. So that's from the protection perspective. Now, from the management perspective, that's another story, right? Because I want to be able to generate a report to show to my CIO, for example, what are the machines that have been infected, right? So I need a central management solution to do that. And Defender alone does not provide that, right? So you have to look from two angles. Now, with that said, we do have the System Center endpoint protection that works on top of Defender if you have enabled Defender on the machines that will help you generate those kind of reports and help you manage your environment, right? Or you can use OMS, but well, OMS is more for log analytics than actually preventing from malware. From a reporting standpoint, yes. Yeah. Does Device Guard works with App Locker? I don't know. That's a good question. I will say that they serve for different purposes. So if you really want to lock down the box, you can use Device Guard. And App Locker, they have more flexibility in terms of enabling other applications, or especially for a client, compared to Device Guard. I don't have a definitive answer for that. Sorry. Question there.
Just curious if you kind of highlight for me a scenario in which we deploy the defense mechanisms and the server decides to blue screen itself instead of boot because of the malware or recovery, because initially it sounds great to me, but then I realize it kind of would just be another form of DOS attack where they just now take everything offline because it's blue screen before it boots.
Yes. I think that to be able to answer that, I'll need more time than I have right now. So can I ask you to come here after the session and we can discuss that scenario? Any other? There was another question here.
Just curious about developer workstations. They're actually creating binaries, DLLs, and stuff. How does somebody handle that?
Oh yeah, they won't be able to run. Yeah. That's a great point. You don't want to apply device guard policy for development environments, right? Or another option, having a second to think about that. What you can do, you can have device guard as a auditing mode instead of enforced policy. Okay, so another thing still to protect against any environment that you may be running Windows Server is, well, over the time, Microsoft has did some enhancements in the log system inside of Windows and Windows Server, and that's still true for Windows Server 2016. We actually added more detailed information for the logs in Windows Server 2016. So just like we did for the other versions, people say, oh, this log does show that something is not correct, or that I have some kind of suspicious activity, but I can't actually see the details. So customers came to us and said, can you please add the details to the logs? And we did that. The other thing is we partnered with OMS to be able to detect some things that are happening inside of Windows Server 2016 with OMS. So in terms of log analytics, we want to make sure that everything that is popping up in the Windows Server system is catched in the OMS front as well.
Is that what they showed in the keynote?
I was not in the keynote.
They showed a tool where they said it would work in the cloud all the way down to local.
Yeah, so basically what happens is with OMS, you have an agent running on the system, and that is reporting all the logs, and then you can see the raw data in OMS, or you can have the intelligence from OMS that says, look, I detected that the same system showed this, and this, and because of this behavior, I presume that an attacker is trying to do that, right? So the news for OMS is OMS now fully support Windows Server 2016, right? So the things that we added to the logs in Windows Server 2016 is now OMS can understand those logs and provide you information about that as well, right? So with that, let me go ahead and show you another demo for OMS, or Device Guard and OMS.
Device Guard allows you to create code integrity policies in the form of a whitelist that specifically define which applications, which utilities, which drivers are permitted to run. Device Guard is common to both Windows 10 and Windows Server 2016. It can be configured to merely audit those binaries, those applications, utilities, device drivers that don't comply with the whitelisted policy. Or it can be configured to enforce that policy, thereby blocking that driver or blocking the utility from actually executing. In addition, Device Guard allows you to lock the policy, which prevents malicious administrators from changing the whitelisted Device Guard policy in order to run some malicious binary or to execute an attack against the server. I'll briefly walk you through how to create a code integrity policy. The first thing you need to do is designate a baseline machine that you deem to be healthy, and you extract a CI policy from it using the highlighted syntax. You then need to convert that policy into the binary form which is required by Windows. Finally, configure various options on the policy, such as whether it's only being enforced on kernel mode components or whether user mode binaries such as administrator tooling is also included. In addition, you can configure whether the policy is in audit mode or in enforced mode. In audit mode, a bad binary will actually run, but it will be logged in the event log. Once you've generated the policy, converted it to its binary form, and configured the desired options, you simply need to deploy the policy. That can be achieved using the group policy shown on screen. First and foremost, we need to turn on virtualization-based security. This enables the strongest form of code integrity. Then go into the Deploy Code Integrity Policy node, configure the path to the Code Integrity Policy file, and you're done. Windows Server 2016 also comes with significantly enhanced logging, as shown in the previous code integrity demonstration. Used in conjunction with Microsoft's Operations Management Suite, you can obtain actionable operational intelligence based on event logs alone. OMS also allows you to gather event data from thousands of computers, both on-premises and in the cloud. And it allows you to visualize that data in various ways across all of those systems through a single pane of glass. To begin configuring OMS, we simply click on the Settings button toward the top right of the pane. Every server from which OMS gathers event data needs to have an agent installed, and you need to tell the agent which workspace it's contributing to. You can obtain both from the Connected Sources tab. Next, we click on the Data tab. In here, we're going to configure OMS to instruct the various agents which event channels they should be extracting event logs from and uploading to the cloud. In my case, I'm going to do both the operational and verbose channels for code integrity. Next, I'm going to go over to the dashboard and I'm going to configure two queries. One which shows me all of the audit logs related to code integrity, and one which specifically shows me any of the binaries that were blocked by virtue of a code integrity policy running in enforced mode. If I want to drill into the data, I can simply click on the corresponding tile. In this particular case, I can see that there were 89 audit events related to code integrity that were generated by 5 separate computers, as shown by the list on the left side. I have a couple of options in terms of consolidating this data. First, I can simply flip it into table view, which consolidates the view slightly, making it a little bit easier to digest. If I'd like to take that consolidation further, I can use the minify capability, where I have a sensitivity slider bar that allows me to dictate to OMS exactly how similar the events had to be in order for it to consolidate them. This allows me to bring the consolidation view down to the file and the number of occurrences of that file that generated a code integrity related audit event. In this video, we've shown how Device Guard provides hypervisor enforced code integrity policies. We discussed Windows Server 2016's enhanced and very fine-grained event logging and highlighted that capability using Device Guard. In conjunction with Microsoft's Operations Management Suite, we also showed how it's possible to consolidate thousands upon thousands of these code integrity events into the most commonly recurring offenders, allowing us to mitigate an otherwise unseen problem.
So the two last items that I wanted to talk about are protection to the virtualization fabric and to new application models. So let's start with the virtualization fabric. And you probably heard about this feature at this point, so some of you have been to the session that Jeff Woolsey presented. Basically, we are talking about shielded virtual machines in here. And the thing that we are trying to protect against is, if you think about regular virtual machines, as an administrator of the virtualization host, and no matter what the virtualization product I'm talking about, Hyper-V, ESX, Citrix, Zen Server, whatever virtualization I'm talking about, as an administrator of that host, I ultimately have access to the virtual machines. I can have access to the disk of the virtual machine. I have multiple ways to have access to the content inside of the virtual machine, right? This is exactly what we are trying to protect against, right? Question, how many of you are running VMware today? As usual, the vast majority is running VMware. How many of you are running Hyper-V today? Well, still a lot. How many of you are running both? Okay, Citrix, anyone running Citrix? KVM? Okay, well, there are others. These are the main ones, I guess. All of you, you are exposed at some level to this vector of attack, right? And Jeff was talking about this. I think he explored, if you have been to the session that Jeff was delivering this morning, he talked about most of the vectors of attacks. There's one that he did not talk about that I'm going to talk. So what we're trying to accomplish here is, no matter the level of access that I have to the virtual machines, as a Fabric administrator, I shouldn't touch the data inside of the virtual machine, right? So I could explore a lot of vectors in order to end up having access. So in order to provide a real security for this virtual machine, we have to think about what are the security features or mechanisms that we have for physical machines, right? In a physical machine, a server administrator will and should have access to the content inside of this physical machine, right? If I have a domain controller running on a physical machine, the Active Directory admin needs to have access to that information, right? Does the storage admin should have access to this? The network admin, backup, virtualization host? No, they shouldn't have access to this information. How do I protect a physical machine? Well, first of all, I have to encrypt the storage, right? And I have to use network security features like IPsec or whatever it is, or HTTPS or whatever mechanism it is to protect the connection between the nodes inside of my network against man-in-the-middle or spoofing or whatever it is, right? Now, there's one additional layer of security for physical machines, which is I put the server in a cage with a padlock and another padlock, and then I put a camera, and then I build a wall with fences, and you get what I'm trying to say, right? What about a virtual machine? Well, a virtual machine is a file. Let's start from there. So at the end of the day, the storage administrator, network administrator, backup operator, all of those roles will have access to this file at the end of the day. Now, just like we did for physical machines, why don't we just encrypt the virtual disk, right? Because that's not enough. If I only encrypt the disk of the virtual machine, guess what happened when you turn on the virtual machine? The disk is decrypted, right? There are other vectors that even if I can't have access to the disk, I could use to have access to the information inside of the virtual machine. Like, for example, attaching a debugger to the virtual machine process. It's not that complicated, right? So we want to provide the same level of security for a shielded virtual machine as we provide for a physical machine. So the first thing that we did was we created a virtual TPM, the Trusted Platform Module, that has nothing to do with the physical TPM in the host, because we want to be able to live migrate the virtual machine. for this shielded virtual machine. So the shielded virtual machine has BitLocker, for example, available. Also, this is a generation 2 virtual machine, so we have secure boot, we have measured boot, we have all the mechanisms that we provide for a physical machine, for a virtual machine. But, okay, so what are we preventing with that? If I have access to the disk is encrypted. If I have access to the Hyper-V Manager interface, I can double-click the virtual machine. I would have access in a regular virtual machine, but with a shielded virtual machine, that process is protected, so I can't see the console of the virtual machine. I can only access through RDP, which is fine because then we have the certificate for that. So the virtual TPM basically prevents an administrator from stealing the disk and seeing the content of the virtual machine because they have access to the video memory. Fine, that's awesome. As a persistent attacker, I'm going to explore other vector of attacks, right? And that's the part where we start to differentiate from what VMware is launching in their vSphere 6.5 feature called VM encryption. VM encryption provides that, but without the virtual TPM. Basically what they do is they encrypt the disk in the storage, and once the virtual machine is running, you can actually have access. But that's the part where we start to differentiate. Why? Because as a persistent attacker, what I'll try to do is I'll try to explore other vulnerabilities. Like for example, if I can't have access to the disk, if I can't have access to the virtual machine, what is the logical next step? Network, we protect with shielding the live migration workload. VMware does that as well, right? But that's a good point. What is the next logical step? Let me take, he mentioned RAM, the memory, the host. Yes, let me attack the host. If I can have access to the host, I end up having access to the virtual machine, right? No, remember the device guard? In order to run shielded virtual machines, one of the things that you do is you implement device guard, right? And then another feature comes with shielded virtual machines, host guardian service. What host guardian service is a separate entity that hosts the keys to decrypt the shielded, the encrypted virtual machine in the Hyper-V host, where if I want to turn on this virtual machine, the Hyper-V host needs to contact the host guardian service and ask for the key. Now, it's not just, please give me the key. It's, can I have the keys? And then the host guardian service will say, okay, show me your code integrity policy from device guard so I can give you the keys to decrypt this virtual machine. If the host guardian service analyze the code integrity policy and other logs along with the code integrity policy, it's a non-healthy host approved to run this virtual machine, then the host guardian service will provide the key to decrypt this virtual machine. Right? So I can't actually attack the host. Now there's something going on here with this transition, this animation of the key that I could exploit. Right? Which is, let's take the key. Now remember the VBS? That key is stored in the VBS, the virtualization-based security. So you can't have access to the key. Right? Okay, so what is the next logical attack vector here? I can't have access to the disk. I can't have access to the virtual machine. I can't compromise the host. Okay, this is for what's running. As an attacker, one of the things that I could do is let me explore the file from which every single virtual machine is created from. The template disk, right? Every virtual machine is created from a template nowadays, right? You don't create a virtual machine and then you go insert the ISO file. You should do that, but usually you create from a template disk, right? So if as an attacker, I can explore the disk, I'm running out of time, so let me say sorry for you guys, but I still have some things to talk about. If I can have access to the disk from which all virtual machine is created, if I attack that disk, that template disk, I'm able to attack every single virtual machine that will be created, right? You can't, because with shielded virtual machine, in order to create a shielded virtual machine, we basically see the template disk, and we measure every single block in there, and if you change that, and that's not approved, we don't allow new shielded virtual machines to be created from, right? Next, logical vector of attack. As a workload administrator or as a tenant, every time I need to create a new shielded or a new virtual machine, I usually go to a portal, right? And there's one key information that I need to provide to create this virtual machine. What information is that? The username and the password for that virtual machine, right? To manage that virtual machine. What if, as an attacker, I could explore the portal? I can implement a malware in that portal that logs the username and the password, so I can have access to the users inside of the encrypted and shielded virtual machine. You can't, because in order to create a shielded virtual machine, you don't provide username and password. One of the things that Jeff showed this morning is you actually create a shielding data that it's encrypted by itself, which has the RDP certificate and the username and password along with other information in order to create the shielded virtual machine, right? So if you think about, there are many vector of attacks that I could exploit in order to have access to a highly secure virtual machine. We protect against all of the ones that we know about with shielded virtual machines, right? We do have some customers running shielded virtual machines today, although we just launched Windows Server 2016. We worked with some partners and customers in order to deploy. This is the hoster that Jeff mentioned in the session this morning that is already running shielded virtual machines. Basically what they are saying to their customer is, you have the option to run a regular virtual machine with us, but if you have a highly secure workload that you want to make sure that even we can't access that information, you can create a shielded virtual machine. Be aware that if you have any problem with the virtual machine, we can't have access as well, right? This is important to know. So I really encourage you guys to take a look on shielded virtual machines. I'll skip the demo, of course, because of time constraints, because I still want to talk about just one last thing, which is containers and nano server. This won't take long. So you heard about containers. Containers is basically the virtualization of the OS instead of virtualizing the hardware. So every single container, different from a virtual machine, the containers will share the same kernel, which from a development perspective is great. But because they are sharing the same kernel, there are some security issues related to that, right? So one of the things that we did for Windows Server 2016 was we created Hyper-V containers. And Hyper-V containers are hypervisor isolation for containers. So every single container will have its own kernel. You don't actually manage that kernel. You don't have to look at that kernel as a new operating system that you have to manage. It's self-contained. It's a self-contained kernel. But because we implement that, we remove the security constraints from running containers in a production environment, right? And the last thing is nano server. Now, I'm going to talk about nano server and containers tomorrow in my session, so if you have more questions about this, I encourage you to take a look at the session tomorrow. But nano server by itself is already a very big step in terms of security. Because one of the things that we like to talk about is the size of nano server is only 400 megs. Now, the other side of it is we have less ports open, we have a smaller attack surface, and we have also performance as well. But from the security perspective, it makes a lot of sense, for example, to run my Hyper-V server as a nano server because I have only the services, the ports, the registry, the file system to support Hyper-V, not the other features that may be present in the server, right? So I really encourage you guys to take a look at Hyper-V containers and Nano Server as well. Right? To summarize, here are the list of features that we brought to Windows Server 2016. As you can see, we kind of divided from things that you need Hyper-V to run and things that don't necessarily need Hyper-V. So if you think about running Windows Server 2016 on top of VMware, on top of AWS, you still have a very secure operating system. If you are running on top of Hyper-V, there are some unique things that we did for the fabric in the industry that no one is actually talking about. Right? I'll be here for a few moments to answer other questions. I'll be at the Ask the Experts. Thank you very much for being here, and see you guys later.